Welcome once again. I am Anjali Mishra, Assistant Professor of Pharmaceutics at Noida Institute of Engineering and Technology, Pharmacy Institute, Greater Noida. So, in the last lecture we saw about the different evaluation test of suppositories. So, before I begin, let us have a quick revision of what we studied in the last lecture. So, let us start. Before understanding the melting range test, as you can see on the screen, let us have a quick revision of what we have studied in the last lecture. So, we studied about suppositories. So, what are suppositories? Suppositories are solid dosage form which are intended to insert into the various body cavities that include your rectum, vagina, nose, ear cones and sometimes urethra as well. So, as we were discussing yesterday, that we had certain parameters to check the suppositories that we had formulated. So, these parameters are enclosed under one roof which are called as evaluation of suppositories. So, in the last lecture we saw two important tests. One of them was the appearance of suppositories. Now, appearance of the suppository is very important because whenever we see any dosage form, the appearance plays a very vital role in order to enhance the acceptability of a particular dosage form by patient, by medical professionals. So, the appearance plays a very vital role. The second test we saw in the last lecture was uniformity of weight. So, we saw that when we weighed around 20 suppositories, we came to the conclusion that not more than 2 suppositories should vary from the range of 2.5% of total weight of entire 20 suppositories. So, that is how we calculate the uniformity of the suppositories, because when we calculate the uniformity, it helps us to understand that some suppositories, if they remain overfilled or if some of the suppositories remain underfilled, then that can be evaluated and suitable corrections can be done. So, moving on to the third test which is mentioned here, melting range test. Now, melting range is what? Melting range is something that plays a very vital role in understanding suppositories, because until a suppository melts, it is not going to produce any action. The action is evoked only when suppositories are melted properly. So, melting range test help us to understand that how far the suppositories are melted and at what temperature they melt, so that a proper efficacious dosage form can be formulated. So, let us try to understand these tests. This test is also called as macro melting range test. So, it is basically a measure of the time that is taken by a particular suppository to melt on a particular area where it is being inserted, that is to any of the body orifices. So, here the suppository is completely immersed in the constant temperature water bath. As we can see in this diagram, we have got an apparatus, a sophisticated apparatus which consists of a water bath, and here the most important and the vital thing that is to be noted here is the temperature of the water bath must be maintained somewhere around 35 to 37.5 degrees Celsius, because as we know 37.5 degrees Celsius is the ideal temperature of human body and which is going to provide an environment for the melting of the suppositories. So, here in this apparatus we ensure that there is a constant temperature water bath. So, we measure here the time taken for the suppository to melt in the water that actually surrounds that particular suppository. Now, here the most important thing that is to be noted here is the time taken, because what we are measuring is the time actually taken by a suppository to melt into the surrounding where it is placed, which is also going to understand that how far and how quick our suppository is going to produce action when it is inserted into particular body orifices. Understanding melting range test, let us move ahead. So, here in the melting range test, when you understand the melting of the suppository, in addition to this we also come to know the in vitro drug release pattern. So, simultaneously when we see and understand the suppository's melting temperature or the melting point of the particular suppository, simultaneously we can also take out the in vitro drug release pattern of a particular suppository, because just imagine if we have placed a constant water bath which is maintained at 37.5 degrees Celsius and we have inserted a suppository for which melting range apparatus has to be calculated. So, once you have taken the melting point of a particular suppository, at the same time this suppository has it has melted and it has dispersed its constituents into the surrounding water, then at regular intervals this constituents can be taken out from the entire vessel and aliquots could be checked, and this is how the in vitro drug release pattern of a particular suppositories can also be studied. Then in order to calculate the final result, what we do is we plot a graph of time versus drug concentration curve, which is also known as in vitro drug release pattern, can also be taken out from this entire thing. So, here this is a very advantageous test because at the same time from melting range we can also calculate the drug release pattern of the suppository. So, this is another test which is used to evaluate the efficacy of a particular dosage form, specifically suppositories. Now, understanding the another dosage form, that is liquefaction or softening time. So, as we are discussing about suppositories, that the melting of the suppositories is a very vital step in determining the dosage form. So, softening or liquefaction of suppositories is actually a rate determining step here. So, it is very important to understand that at what temperature our suppositories is going to become soft or it is going to liquefy itself, so that it becomes a portable agent to deliver its constituent into the surrounding area and to treat the particular disease. So, let us understand liquefaction or softening time. So, a modification of the melted was developed by Crown Sky scientists is definitely another useful test for determining or for evaluating the suppositories. So, liquefaction or softening time is a slight modification of the test that we just saw in the previous slide, and this test was developed by this scientist known as Crown Sky. Now, here it consists of a U tube which is partially submerged in a water bath, and that water bath is also maintained at a constant temperature, and specifically the temperature is going to be around somewhere around 35 to 37.5 degrees Celsius. A constriction of on one side hold the suppository in place in the tube, because that is a tube. So, whenever we want to perform any test on that particular suppository, it is very important to hold the suppository properly. So, for holding the suppository, a constriction is placed here, so that suppository is holded at one place in the tube. A glass rod is placed on the top of the suppository. I hope it is easy to understand that when there is a constant water bath maintained here, and in that we place a suppository. To hold that suppository, initially what we do, we attach it to a particular constriction. So, let us imagine that this is a constriction which is holding the suppository properly, and on the other hand what we do, we immerse or we try to insert a glass rod, or we try to initially touch that glass rod on the surface of the suppository. So, here we can imagine that here is a glass rod present. Then what we do is we see the time for the glass rod to pass through the constriction, and that is recorded as the softening time or the liquefaction time of that particular suppository. See, to be more clear, I would like to once again tell what is happening in this test is, what we are doing is we are taking a constant water bath. What we are doing is we are taking a constant water bath. This water bath is maintained somewhere around a temperature of 37.5 degrees Celsius, and we are inserting a suppository of which liquefaction test or softening temperature is to be determined, and this suppository is held at a proper place by a constriction, and at this point we have attached a glass rod or any of the rod which is going to penetrate or which is going to immerse into the suppository of which evaluation is to be done. Now, slowly and slowly we will apply pressure and will allow this glass rod to pass through the suppository. Now, at what time or the total time taken by the glass rod to penetrate into that suppository is being noted, and this temperature and that time is nothing but your softening time. So, in order to assess the suppository, in order to evaluate the suppository, if you want a good suppository that is going to produce a quick action, definitely the softening time must be quite less. As less as the softening temperature, the biological action produced is definitely going to be faster, definitely going to be the quick. So, moving ahead, let us understand liquefaction or softening temperature in a bit detailed manner by looking at this apparatus. So, this can be carried out at various temperatures from 35 to 37.5 degrees Celsius, as I mentioned earlier, as a quality control check and also be studied as a measure of physical stability over time. So, as we know that the storage condition of suppository is definitely a challenge for all of us. So, it is very important to understand that whatever suppositories, if it is placed for a period of 2 years or 3 years, or even if it is placed kept for a period of 1 year, that whether during this entire period it has maintained its shelf life or not. In order to check the shelf life, this test plays a very vital role. So, here what we are doing is we are measuring the physical stability of the suppository as well in along with the softening temperature. So, this temperature or this test help us to understand, or it is a very important quality control check of suppositories. A water bath with both heating and cooling elements should be maintained here, as it is very important. So, if heating and cooling are maintained simultaneously or done simultaneously in the same water bath, so quick evaluation of suppositories can be done. There won't be any hindrance of changing of water or heating or cooling of suppositories. So, this is a very important test, and here we can very clearly see this diagram, which includes how a testing apparatus of suppositories is looks like, and how liquefaction or softening time can be measured by working on this apparatus. Now, let us move on towards the next test, known as the breaking test. So, before I begin with the breaking test, let me tell you all, suppositories, as I discussed in the previous lecture, suppositories are have a tendency actually to get brittle if they do not have a proper mixture of base and API. For example, as I mentioned in the previous lecture, if we are using hydrogenated oils and if we are cooling it very rapidly in a refrigerator, or we are congealing it in a refrigerator, there is a high risk of suppositories getting brittle. And as the suppositories is going to get brittle, what is a major thing that is going to come in our mind? That the constituents of the suppository is definitely going to ooze out from the particular area. We won't get 100% efficacy of that particular suppository. So, definitely this is not a good idea, that brittleness of suppository is a completely undesirable effect. So, in order to study this effect, let us understand what is breaking test and how do we evaluate suppository with this breaking test. So, brittleness of suppository is a problem for which various solutions have already been described. We just saw the melting apparatuses, we just saw the breaking point, we just saw the liquefaction temperature. So, brittleness is already been studied through various parameters. So, this is another test. The breaking test is designed as a method for measuring the fragility and brittleness of that particular suppository. The apparatus is used for consists of a double walled chamber in which suppository is placed. Again, water bath is maintained at 37 degrees Celsius, is pumped through the double walls of the chamber, and suppositories contained in the dry inner chamber to supports a disc to which is attached. So, breaking test apparatus looks similar to the dissolution test apparatus that is being very widely used in order to study the dissolution test of tablets, capsules. So, it is similar to that of the capsule. However, the dissolution test apparatus is not going to hold the suppositories in a proper place, and the suppositories is going to spread haywire. As a result, we attach a disc, that is, there is a presence of a disc in the inner chamber of that particular apparatus, which is going to hold our suppositories in a proper place. Let us try to understand breaking test in a more deeper way. So, the other end of the rod, which consists of another disc to which weights are applied, are placed amount at least weighing more than 600 gram on the platform. Initially, what we do, if I say that this is a dissolution test apparatus, this is a dissolution test apparatus, we have placed our suppositories somewhere around here. Let us imagine these are the suppositories and we have placed it here at a water bath which is maintained at a constant temperature of 35 to 37.5 degrees Celsius. What happens here is we are attaching certain amount of weight which is going to vary from 200 to 600 gram. So, at particular time interval, so here we can see at 1 minute time interval, we are going to increase the weight by addition of 200 gram at each interval. So, we can just imagine that we are attaching weight to this suppository. At each time we are increasing the weight by 200 gram. For example, at 1 minute interval, we have attached 200 gram initially. What we are going to do at the second minute, we are going to attach more 200 gram. So slowly and gradually we are increasing the weight by 200 grams. So when we are increasing the weight, what we are measuring is, we are measuring the breaking point of the suppositories. As you can see, we measure the breaking point or the force that is required to break a suppositories or make it brittle basically. Different shaped suppositories have different breaking points. Here the point is very important. Different shapes of suppositories is definitely going to have a different breaking point. If the suppositories are supposed to be placed in the rectum, it is going to have this size, and definitely the size of this suppositories might vary. For example, if we are making pessaries which usually have the size of a disc shape, definitely the time taken by the suppository is going to vary. So breaking point is definitely is going to vary depending upon the size, because as we know, as the size differs, the distribution of forces is also different at each and every point. So when we are adding weight on this suppository, definitely we can take a case here that pessaries is going to break at 600 gram of, when you apply 600 gram of weight. So here the breaking point of that pessary is going to be 600 milligram. However, in the case of rectal suppository, even if I attached 200 gram weight, there is a breaking point achieved. So I can say that pessaries have got a higher breaking point as compared to the rectal suppositories. So breaking point or breaking temperature help us to analyze at what time or at what weight the suppository is going to break or it is going to become brittle. Moving on. This is another test known as the dissolution testing. Now dissolution testing is quite famous testing, that because be it your capsules, be it your tablets, the testing is going to remain same only. The things, the water bath, the apparatus is definitely remains the same only when I study about dissolution testing. So testing for the rate of in vitro drug release substances is actually a difficult problem when it comes to suppositories, because the main attribute to this problem, because of the melting deformation. What happens when you are testing your suppositories, when you are actually you want to test the dissolution of the suppositories outside its parameter, sometimes what happens when you take out the suppository from its packet, there is already softening already happened, or liquefaction have already been achieved there. So actually testing of the dissolution parameters of suppositories is quite a challenge for researchers or for academicians or for students. It is actually a problem, because initially when the suppositories have already lost their shape or they have deformed, so we can imagine certain amount of medication already have been melted or they have been deformed. So some amount of drug has already been lost initially. So in order to cope with these things, in order to study the dissolution studies, there is definitely a big challenge for all of us. So dissolution testing is actually a challenge. Now as I have discussed in previous slide, that when we are performing melting range test for evaluation of suppositories, so simultaneously we can also perform the in vitro drug release pattern of a particular suppositories. So because we know that whenever a suppository melts, it is going to liberate its constituents in the surrounding area from where it is melting. So it is actually very important when we are performing this test, and just now discussed that melting point of suppositories is important to study, because it is going to help us to understand at what point the suppositories is going to melt and at what temperature it is going to show its actions, so that a proper efficacious dosage form can be built up. However, when I am talking about dissolution testing, again and again I am saying the testing of suppositories is quite a challenge for any person who is performing this test, because of the stringent storage conditions that a suppository requires as a result. Now here, however, in order we can put an effort to minimize this problem, to minimize the duration. So what we have done, we have actually caused a slight variation in mass or in slight medium interface. Various means have been also employed. Now this means includes wire mesh basket, membrane to separate the sample chamber from the reservoir. As I have discussed earlier that we have got various sophistication of instruments that includes your wire mesh basket that actually looks like, so this is going to be your mesh, and here the actually this is a mesh on which you can place your suppository very easily, so that the suppositories do not get spread haywire into the surroundings or they do not move anywhere here and there. So, this is how you can maintain its integrity properly, and the test of the dissolution can be done very carefully without any issues or without any disturbance. So, this is a mesh that has been, so slight modification has been done here, we employ mesh instead of that entire basket. So, dissolution plays a very important role to understand that at how much quantity of the drug enters into the media, and what is the actual highest concentration that has been achieved into the media. So, this is a very important test. Now, understanding this test in a more deeper way, so here is the apparatus which everyone is familiar, because this is the same apparatus that has been used for the dissolution testing of the tablets and the dissolution testing of capsules. Now, here the sample is sealed in dialysis tubing or natural membranes that has also been studied. As I have discussed that the placing of suppositories is actually a great hindrance in studying the dissolution. So, instead of using the entire basket thing, what we do is we use a mesh or we use a particular membrane. Now, the membrane can be a natural membrane or can be a nitrocellulose membrane or it can be any membrane on which your suppositories is going to be placed. Now, flow cell apparatus has also been used in holding the sample in place with cotton, wire screening, and most recently with glass beads. So, instead of using the traditional batch basket type apparatus, we are definitely making a slight modification. We are going for the wire mesh basket, or we are employing the membranes, different kind of membrane. Here, in order to study the dissolution parameters of suppositories, we are even employing the flow cell apparatus in order to study the dissolution test of the suppositories. And this is a very simple apparatus of dissolution apparatus, which is used to study the dissolution test of a particular suppositories. So, that is all about the different evaluation parameters of suppositories that we have just now seen. That includes your appearance test, evaluation test, and different types of parameters like uniformity of weight test, melting range test. So, these tests are actually very important, because whatever suppositories you have made, until and unless it is evaluated properly, its efficacy can't be tested, and until and unless you test the efficacy of a particular dosage form, you do not know how good you have manufactured or how better is the manufacturing thing. So, that plays a very important role and vital role. Going through all the parameters that we just now went through, all the parameters of evaluation test, be it your breaking test, be it your melting range test, be it your softening temperature, or sometimes the appearance of the suppository. All these tests each have their own importance in evaluating the suppositories. Whenever suppositories are formulated, after formulation, the very important and vital step is their evaluation. If the suppositories do not pass the tests that are mentioned under the evaluation criteria, then the suppositories, it means they are not of the standard quality, not of the standard measurements. So, such suppositories are often discontinued from the batch, and such suppositories have to be discarded. So, in order to understand that the material, the manpower, the skill, the time that has been employed while making suppositories is also completely wasted. So, it is better not to go haywire and understand the different evaluation parameter of suppository. So, thank you so much, and I hope evaluation of suppositories might be clear to everyone. So, thank you so much.